Welcome to Tech Tips Africa as we look at how to troubleshoot network connectivity problems using 4 commands that come with most of the computer operating systems, namely the ipconfig, the ping command, traceat, and the pathping command. We shall begin with ipconfig, a tool that we use to collect computer network configuration details such as the IP address. Let's get on with it. If I issue an ipconfig at the command prompt and press the enter key, these are the results we get. The configurations are related to the Network Interface Card (NIC), also known as the LAN adapter card. You notice that the state says that media is disconnected, pointing to a problem at the physical layer. If you face such a scenario, check for issues such as missing or loose network cables to your computer or the power to your Wi-Fi router if you're using a wireless LAN. In my simulated situation, the Wi-Fi connection is turned off. I'll go ahead and establish connectivity and then reissue afresh the ipconfig command. Notice that now we've obtained an IP address, a subnet mask, and a default gateway from the wireless router. The default gateway is the IP address of the device that leads from your computer to the internet. Now that we have an IP address to our machine, it's time to look at the ping utility. Packet Internet Grouper, ping in short, is a command that tests connectivity between two nodes. Nodes here meaning a computer, a network switch, or a router. I'll begin by testing connectivity between my laptop and the default gateway, which is my wireless router. Yes, we have connectivity between these two with a round trip time of 1 millisecond, or the RTT. This is the time a data packet travels from one node to another and back. Right, we've established that we have connection to the default gateway. It's now time to test connectivity to the internet. We can do this by doing a ping to www.google.com. Unfortunately, this fails with an error that the ping request could not find host. This means that my machine has no access to a DNS server or a translator that can map the name www.google.com to an IP address. To circumvent this challenge, we can instead issue the ping using an IP address that is used by Google servers, 8.8.8.8. We now get a different error that says request timed out. Out of the 4 packets that we've sent, we've received back none. This means that we have no connectivity to this particular Google DNS server. We can safely interpret this as lack of connectivity from my computer to the internet, as it is extremely rare for the Google DNS servers to be unavailable. Now, to better understand how the data is moving towards the server, let's invoke the next command, traceat. Traceat helps us to identify where along the network we are experiencing connectivity problems. Let's go ahead and issue a traceat command to the Google DNS server 8.8.8.8. It says that we are tracing the route to 8.8.8.8 over a maximum of 30 hops. This means that if the packet traverses 30 nodes without reaching the IP address we are attempting to reach, it will consider the destination unreachable. Right. Here we see that the data goes first to the default gateway, and at the second hop reports back that the destination is unreachable and that the trace is complete. The node responding has a public IP address and can either be our router's public IP address or that of our immediate internet service provider, ISP. To resolve this, check that your internet router has a connecting cable towards the service provider, or that your router is powered on. If all seems fine from your end, then engage the ISP to check on their end if they could be having issues with the connection. Coming back to my simulation, the cable leading to the internet was disconnected. I'll hook it up and reissue the traceat command. This time round, we see that the trace is successful. We also see the data packets as they cross various nodes. For instance, the third hop is that of my ISP, accesskenya.net. Traceat sends 3 data packets to each node and displays the time it takes for a round trip by each packet. And that's why you see 3 columns with times in milliseconds. Ideally, this should be more or less the same in values, unless there are underlying network issues with the node that is being probed. Typical time value should be 30 to 50 milliseconds, or at the very least, less than 100 milliseconds. Greater RTTs indicate network issues, such as traffic congestion leading to slow internet speeds, and the concern should be raised with your ISP. Lastly, we touch on the pathping command. This is very similar to traceat, except for the fact that it collects more data from each node over a period of 25 seconds. In a way, it gives a clearer picture of the network performance from each and every node along the network path. Let's do a path ping to dns.google. Here we see that the command has collected performance statistics over a period of 200 seconds from the 8 nodes. It also captures any lost packets along the path. Finally, we see that the packet arrives to its destination at dns.google.com with an RTT of 45 milliseconds, thus confirming that we indeed have connectivity to the internet. Alright, thanks for watching, and I hope you've learned something new. In case you've not subscribed to this channel yet, please do so and turn on the post notifications to receive alerts whenever I upload more tech tips.